from the selected conference topics, from the people that were there. So you had the decision makers, engineers, and then also in the presentation, people were really sharing insights into their processes. And that was quite something unique.
Yeah, we had a lot of talks and telephone calls before, and asking them, can you maybe show a short movie to get an impression of everything, and please show the parts, dual shot, and whatever. No? And we have about 14 OEMs. Yeah. It was very much, and I think in general, including suppliers, it was a very good conference at least. Yeah. And of course, it depends on the participants. No? When they are not there and feel comfortable and everything. I think that the evening location was also very good in the Old Brother Church, and so all that together was a good cake. Yeah.
We tried to go to our hotel. I tapped Mr. Johnson on the shoulder 10:15, and it was 30 meters to walk, and it took us 2 hours, 15 minutes to walk that because we stopped at every table, discussed alloys, software. Hello and welcome to the Gigacasting podcast. Today we are excited, I would say thrilled, like small kids in a candy shop with free money, because we're going to talk about the first international Gigacasting conference at all on this globe. And the reason why we're so excited that this episode, we also have the pleasure of having Professor Martin Fehlbier with us, the man of the hour.
Hello.
Welcome.
Thank you very much for the invitation. Pleasure for me. Thank you.
It's our pleasure, I bet. So, you are the creator of this conference. We have a number of questions. We know that you're a busy guy, so we'll try to keep it short.
You're welcome.
But before we start, could you please give a short summary of yourself and the GTK?
Yes, I went to school in Cologne, and afterwards I made an apprenticeship as a foundry mechanic at Honsel AG. And so I learned all the basics from forming and casting. And afterwards I went to the RWTH Aachen University, and there I studied metallurgy and material science, and it was a special focus on foundry technology. And I made my exam in 2002, my PhD exam, and then I became a senior and researcher and group leader. And from up to 2005, I was a chief engineer and vice director of the Foundry Institute, RWTH Aachen. Then I went into the industry afterwards. From 2006 to 2009, I was the chief engineer and tool shop leader and foundry and research and development and simulation leader from Pierburg, Kolb-Schmidt Pierburg in Nettetal. Then I went to Volkswagen Kassel, was the head of the technology center and production of high-pressure die casting, aluminium and magnesium structure parts at Volkswagen Kassel. And since October 2012, I'm the professor here and the head of the Foundry Institute, GTK.
GTK is the heart of R&D in castings in Germany, I would say, or Europe.
Yeah, in the leading group, I think there are also others in Aachen and Munich also too, of course. But we really care for thin-walled structure parts, aluminium technologies, about materials, about an increase of processes and measurement instrumentation, material development and all this stuff. Also magnesium tixomolding, for example. In this case, we belong to the leading research institutes, yes.
Yeah, it's very impressive. Both your career and the GTK.
Absolutely. Also, extrapolating from that, thin-walled, large castings. So Gigacasting was basically on the floor. Or how did you get the idea to form that conference about large castings like battery trays or rear floors?
Yeah, at least every 2 years, we carry out a GTK colloquium at the University of Kassel. And I think we all could observe at Eurogus or also a GIFA fair a dramatic increase of the part sizes, of machine sizes and everything, especially from Asia. And so we got the idea to focus on this development of bigger parts and so on, bigger machines. And I think that it was a nerve of many people to get deeper, to get more knowledge about that. And now we are here with a big conference,
Yeah.
on that. Yeah.
I never seen a new design concept becoming a de facto standard that fast as Gigacastings. It seems that it just went in there in the car designers' heads, and 2 years later everybody has a rear floor in planning or in production.
Yes, I think it's a dramatic change for the production, and everybody is thinking about the future, what technologies will be the best choice in future for bigger parts. And now we can have methods to save hundreds of parts in only one single casting. That is a dramatic change, I think. And of course, everybody is focusing on cost optimization of efficiency and also quality through innovative production technologies. And I think we have to open our heart for that.
Yeah. So the natural question comes then, is there anything that can stop this development of larger castings?
I think there will be, of course, for a standard foundry, will be very high costs, even in brownfield. And you need a lot of development cranes and furnaces and so on. So you have to be close to the OEM to reduce logistic costs and long distances. But at least you have a big chance to get involved into new production methods. And so everybody should be aware of these new chances to follow them.
It's a new market.
Yeah, absolutely. Yeah.
And I think also for the foundries or for the foundry industry now as a whole, it's a totally new connection, as the sheet metal guys, they were on the premise of the car maker for centuries. But now casting comes along and joins them also on the premises. So you see it every day, not just delivered to the gates. You really see the production, and that's something that also helps. And I think also we've seen the different concepts around the globe. When we look at the Chinese tier ones that presented in the conference, bigger machines.
Yeah.
Whereas in Japan or North America, it was like, okay, we have to find what is the sweet spot for us. And in Europe, it's more like, what can we do with our existing machines? And to see that contrast and so many different ideas out at the same time about the same thing, I think that's really fascinating.
Yeah, and then the chance to dramatically reduce of numbers of parts and assembly processes. You can save about 30% of the shop floor and about 300 of the robots, for example. So you have a much lower invest in some cases, but you can also reduce the CO2 emissions, for example, with one single part. But the question is, biggest? Will that be the future? Well, when will it find an end? You have a front body, a rear body, then the battery housing. What really makes sense? Also in repair questions and everything. Yeah, you have to be careful. So it's not a self-running process. You have to really think about what is sensible, what is the best investment case for us, for my part. It depends on the part. It's not a self-running process.
But if one might ask, the R&D needed, because I had a question from some people here in Sweden, and I said, I think it will be an intense R&D for 15 years. And then I will, of course, had the question, okay, what kind of R&D? So I would like to put that question to you, Professor Fehlbier. What do you think will be the main R&D topics that people need to develop for the next 10, 15 years?
Yeah, I think we need much more knowledge about the material behavior in the die, of course. It's a quite black box still for many people, and we need much more sensors, measurement, instrumentation. We have to know how the material is running. What is the material behavior after long flow distances, for example, oxides, inclusions, porosity, etc. And of course, we need also much more knowledge about melting technologies, about distortion of the parts. Use heat treatment should be improved, or maybe without heat treatment of the parts. So we need new materials, for example, with lower silicon content, with 2%, or now we have 7%, maybe down to 2% silicon. These are alloys you cannot cast in standard processes, but maybe with Gigacasting in the future, yeah, and with new processes, you can get much better in future, yeah, than today. So we have to open our mind and stop the way of thinking we had until now, and open us for new technologies, new methods. And the worst case would be to stay where we are, no, and to be afraid for anything. Yeah, that would be wrong. Yeah. Yeah.
But you talk pretty much about the material behavior. Do you see a problem that we are doing too little research on sustainable alloys?
Yeah, there are many activities on research on alloys, but has to be the best choice for the best case you need. And I think, especially in casting, we don't have these alloys we need with much elongation. And nature ductile alloys always have here the heat treatment process. Took a long time for such large parts. It's very complicated, and maybe we have to develop shorter heat treatment processes and also new alloys with a high elongation already, in the castings, and these are challenges we can solve, I think, in future, and we have to work on them. Yeah.
So we probably could see a new alloy standard seeing the daylight for the first time in a few years then.
Yes, of course, yeah.
No.
And we don't need thousands of alloys. No, you cannot handle them. No? Maybe one or two would be the best, yeah? For a foundry. No?
One for the front and one for the rear. Yeah, but one with 10% elongation in the front in the crash zone and maybe 7-8% in the rear.
Yeah.
Maybe that's enough.
Yeah.
But also it depends on what we've seen in other presentations at the conference, that it's not only about the alloy and the mechanical properties, it's also about the recycling content of post-consumer scrap in that alloy. And then also it comes to the energy, what the alloy needs for doing the solidification process, how much heat is generated. And that's also something that has an impact on the tool wear. And when you look at these large tools, we've seen suppliers that showed their 16,000 ton machine. Imagine the tooling cost on that tool. And then you have an alloy that destroys it in 10,000 shots. I don't want to go to my CEO and tell him, oh, the tool is broken again. We need another 150 tons of steel.
And therefore, maybe the Gigacasting process could be a good choice for the future. And I think many people are already working on it. And you have a lower melt temperature and a much slower running first phase. You come down from 5 meters per second, 6 meters down to below 1 meter per second filling velocity. And it will be very good for the lifetime of your parts and of your molds and dies, right?
Yeah. But when you talk about Gigacasting, you need purpose-built machines. When you start using Rheocasting, you can already use your existing machinery. That would make the transition way easier and you get the same benefits.
Yeah. Also, of course, it depends on the parts, right? Yeah.
I thought it was quite interesting without doing any marketing. Now I'm talking my self-interest here. There was a lot of talk about Rheocasting. I kind of love that. It was mentioned on stage several times.
Yeah, I think the Rheocasting is a very good alternative in future to reduce scrap, to reduce porosity, to reduce shrinkage and solidification porosity. And it's not running by itself, the technology. You have to learn a lot in the beginning, of the material behavior. But I think you don't need really more than 600 bar pressure after pressure. It's much below. And so you can also produce parts on smaller sized machines with that technology, and maybe 30%, 40% smaller machines for the same part. And it will save a lot of money. And it's very interesting for the companies. Yeah.
I thought it was interesting that no one was speaking about in the conference. The elephant in the room, productivity. I don't know if you felt the same, but no one wants to show the cards here. And sometimes you hear things on the market. And I think there's a great research area that will be about productivity, to get out the number of shots per hour and also reduce the interruptions in the production. Meaning, basically, productivity.
I think we are working on that very much, and it's not solved, honestly, right now. But I think we have good trials and results already, and to get there, and so we have to keep working here in this field. Yeah.
I think it's also a perspective question, as we had it, for example, in the Ford presentation when they showed us, we're producing 1,000 cars per day, 6 days a week, and just to implement it would could cost us somewhere around 2.4 billion in just losses that we have because we had to stop the production line. And then you had some other Chinese OEMs that said, okay, we're producing 4 different cars with each between 5 and 9,000 cars per month. And it's way easier to get the volume you need in these applications and test it out.
I was very impressed by the BMW presentation. That was, we're going to go this way, but they took a one step back and they talked about the business case. And you had one side talking about bigger and bigger machines, which is a contest in itself. And then you have a bunch of followers, but they have one company in between, which is BMW. I thought that was very interesting to hear him discuss the the money of it, and also with the consumer in focus.
Yeah. I think it's maybe also a little bit similar to Volkswagen. Right now, they are not willing to buy the biggest size of machines. They just say the right sized machine for the right sized part. And I think that a machine size of 4,800 tons up to 6,000 is not that a bad size in the beginning. And of course, you can also weld big parts, also, or no, not biggest ones, but maybe middle-sized parts. You can weld them and join them, and this might be a good solution too, and especially to start, one step after the other. And but when we look at China, of course, we see unbelievable big cars, and then they are coming like a storm over us. And maybe I think China is leading right now. And then there's, of course, Tesla in the States and Ford and others. But here in Germany, I think we focus on to improve our engineering, to improve our standards. And then we make bigger parts. But and the next step, maybe, or the third step would be the castings from above 6,000 tons closing force. Yeah. But they start in smaller size here in Europe. Yeah.
But it is interesting that no machine makers are talking about how to use a smaller machine. It must lie in their interest to sell 9,000 tons instead of 4,400 tons.
Yeah, I think they are talking about a little bit, but they do not make advertisement to buy smaller machines. Yeah, but I think many people are thinking about the way to save money and weight and everything. Yeah, and of course the weight question is also very big. You have about 40% less weight when you save hundreds of parts. When you see you need a big battery in future cars and for the electromobility, and you can save much weight here. That is a big benefit for this technology. At least also.
I see the problem from using topology. I had a very interesting discussions with guys that were experts in topology, and the biggest problem they had was uniform properties. And we all know that close to the ingate you get good properties, but far out in the part you start to have problems. And far out in the limit of the part is where you have the riveting, the welding, everything. So he wanted to move the whole set of parameters out there and said, I don't care about the elongation close to the ingate. It's not interesting for me. Is these guys right, or is this a main concern for the future?
I think we have to think about new cooling concepts inside of the die, or also not only one wall thickness, but when you have smaller wall thickness, you have a quicker solidification, then you have better mechanical properties, and you have to find a good combination of all of that. And there are very new cooling technologies, and I think you can improve local properties of the part, and with that you can go to the required properties. Yeah,
I think it's quite important what we've seen also, that getting a good estimate on what the properties are and what you actually need in certain areas of the casting. Because after 2 meters, it's quite clear that the metal doesn't have the same properties as it has in the beginning.
Right. Yeah.
Depends on who you ask.
Yeah.
Yeah, but flowability, how to get it there, and then what the properties are, and maybe optimizations in the flow, different gating systems, or depending on openings, where to put it in the center, to reduce the flow length, and all of these things play a big important role.
Our dual shot technology, which was represented from LK, Geely, for example, yeah. There are fully new ways of thinking to cast parts and to produce parts, and I think we are still not open enough in our mind, in the way of thinking about new processes and these things. And when we open ourselves, and there will be a new future and ways to produce parts. And we have to open us for that. Yeah.
But speaking about open up, I had a discussion with Markus Hofer at Bühler, and he was discussing something on top level he called multidiscipline teams. That it's a need of getting a much closer cooperation with more players, more process owners to make this happen. Speaking about the tools, the cooling, the simulation people, the casters, the alloy producers. Do you see this happening, or is this something that we need to see?
I think so. maybe Klaus Hansen from Volvo just told on the conference that he has performed his team with senior experts who are very experienced in the flop shore things, but also with younger engineers who can do the simulation and design of the parts and everything. When they work together, you can have a good benefit from that. The experienced parts and maybe the new toolings and simulation people, then you have a good team which will run through all the problems, I think.
Also, you need a quite good communication between all of them, because there's constant change. You find out a new thing. Hey, can you replicate that in the simulation? Oh yes, if we change around these parameters. Oh, and then now we see the problem over there that we had in the CT scan, but now we see it also in the simulation, and that get better in each step on each of the ways.
Yeah, but also you need also the supplier industry very much, I think. No? It's starting maybe with a shot sleeve and also with the furnace people, and you have to melt 150 to 200 kilograms melt in 70 to 90 seconds. No? This is very short time. And you have all these things have to be resynced. Are they still okay, or do they have to adapt it to new process ideas? And this has to come together. Yeah,
the sensitivity is so, and the risk when you have a failure. I mean, if 6 weeks is $2.4 billion for 4 GT in one plant, you can start to think, okay, what is the risk if I miss one shot? Is one car not being fed into the production cycle at Volkswagen, for example? I find it strange that I don't see more risk mitigation people involved.
Yeah.
Maybe it's good in this phase. I don't know.
Yeah, I think the OEE is very important, and I think the people are not fear about this new processes, but they have respect for it. No? Yeah, there are so many things where you can fail. No? And at least everything has to be go into the other. Yeah, and if one thing is not running, then the machine is not running. No? And so you have to think about get involved all these single machines for itself, but also not to overdraw it, to overline it. This machine is not running anymore. That's a challenge, maybe. Yeah.
But I think for once, the hourly rate of your Gigacasting machine doesn't really matter in comparison of the hourly rate of a whole car factory. So having an additional machine for extra support, or when one valve goes out, that's basically a small line in the cost breakdown of the whole car factory.
Yeah,
that is what the die-casting machine makers are hoping.
Yeah.
Yeah.
But that's what you said. You have to have a good team at least, no? And then you have to get involved all the suppliers and their knowledge. And one single person will not run it. And the experience is so important from them. And all together we can get forward in these cases. Yeah.
Yeah, but experience is so interesting because everybody is starting pretty much with a blank sheet of paper. I mean, the guys that have some productive data is actually Tesla. That's been doing this for years and years, and some tool makers that are now up to 55 tools delivered and tested. It's very few spots. If you compare it with a shock tower production, for example, you're up to version 50, and then you have 50 suppliers doing it, 2,500 points of information and knowledge. But here we have got 2, 3, 4, 5. This I see as a big risk going further, that people do investments, but getting the thing up running, deliver every 60 seconds or whatever the pace is be, with new equipment, new alloys, new designs.
Yeah, that's a reason maybe why OEMs have to make the decision at least. No? And without OEMs, and I think Hartmann is an exception. It's a private foundry and head away.
Oh, yeah.
Yeah, and what they are doing, but they are doing a good job, I think, as up to now. They have one 6,000-ton machine right now, and Mr. Kner said on our Congress that he will install a second 6,000-ton machine, but others are thinking about 8,000 or 9,000-ton machines. For example, BYD, I've heard that they will install 2 machines a month until the end of the year. It's unbelievable how they are going forward in Asia, and we have to be aware of that, and that we not will fail because we don't recognize this development.
depends on which side of my brain I'm thinking. Sometimes I think that, yeah, okay, China will overtake the European car industry. But then I remember 1978 on the countryside in Sweden, where I was taught in school that now we are all going to be unemployed because the Japanese have started to ship cars to us. And everybody was running, you know, a yellow Datsun, which was the brand back then. But I don't know. Volkswagen came back. They were in deep crisis then, and they came back with the Passat and the Golf. It was harsh 5 years, I think, for Europe, and we came back after the oil crisis. So maybe this will spur us rather than kill us. I don't know.
Yeah, now they care for the battery housing produced on a 4,300 ton machine. They care for this technology, not the biggest sizes, but big size. And they get now they make the experiences, and maybe they will also follow others to improve their machine and park and everything. Yeah, I think they have started. They're on a good way right now. Yeah. Yeah.
But I think we also have to talk about that the final decider on that is the customer who buys the cars. And the rest of the car has to be good as well, as there's just a few people that buy a car because it has a gigacasting or megacasting in them. And it's more on other things that are important for the purchasing of a car.
I beg the contrary. I bought an Audi A2 solely because it has semi-solid casting hinges in the door.
Okay.
But I think I'm pretty unique in that. Yeah. I told my wife we're going to buy this car. Why? Because it has sticks of castings in the hinges.
Yeah. I think the cars are still too expensive. They have to become much cheaper, and they are. Volkswagen is talking about a car with below 20,000 euros, and maybe that's the door to open this market again for many people.
Yeah, that's definitely a great price point, and I think mega castings can have a big impact on the purchasing price of a vehicle, as it slims down the overhead and the supply chain quite a lot. When you just focus on one casting instead of 120 purchases and 250 supplier quality managers, and then even more suppliers, it's just you do it yourself.
Some of the beginners say that their goal is to save 30% amount of the money, for example. Others say, no, we will not save money in the beginning, but we will save weight. No? And that is very important for us. But at least I think we do need both. Yeah, you also have to save money. You must become cheaper and with better quality also. No? This I think Sandy Munro said about that. We have to go backward from our level of quality. If there is one small gas porosity or shrinkage porosity in the part, it's not that dramatic. Yeah, even the part performance is still there. No? And so we can allow maybe some porosity. And maybe especially in Germany or Europe, the level is too high of quality level.
I think that's another argument why the OEM needs to be the first one to do the castings. Because imagine the discussion between a tier 1 and an OEM about these defects. You have to be very close to engineering and the guys that really knows this part. Where do I have the strength? What kind of exceptions can I do? That will take far too long if you have a multiple layer system like today for castings.
Also, when you put it down in several small pieces, you need way high quality standards to get an overall good quality, as if it's one casting, you have way more load passes. So one defect is not a detrimental failure because you can go around it. But if it's pieced together or welded or glued, then you have to get a higher quality level to get the same overall strength that a casting delivers. And the specifications are designed for the small parts and not for one big casting.
Yeah, I don't want to say that the German or European car makers will reduce their quality standards. That's not true.
No.
But we have to get there that we can simulate better porosity in our parts and what they lead to and the results of that. Yeah, and so we can make a claim for the future what the quality will occur in your part. Yeah.
But don't you see a need for more quality sub-processes? We're looking into, for example, small movable CT scans that could be equipped on robot heads so to be very flexible where you're looking. And I mean, you cannot break the part to know that you have the right properties. So you need to have a different set of testing stations after the casting before you mount it into the car. And I don't see the products on the market right now. Maybe I'm uneducated.
But I think there are, for example, CT lines already in use for 100% of testing. But I don't know how big they can be.
We're using smaller on robots that can circle around.
Yeah, I think AI technology will go also into the processes, or KI, künstliche Intelligenz in German, or artificial intelligence in English. And when all these technologies will be involved in the process chain, we will become much better also, and understand why the parts are good or why they are bad. What do we have to change? Which parameters we will have to change in the process? And that's, I think, it's very important that we care more about KI or AI technologies in our processes.
Yeah, we heard it from Volvo that they're implementing it in their line. He said it during the presentation, and then because we have pretty much ongoing in Jönköping University around it, so we're a little bit sensitive to this. I just made a conclusion. I hear so much about the AI in Gigacasting, so our idea of starting the company Rheosoft, we have killed it now. We're far behind.
Okay, but many are working on those topics, and we cannot say everything. Yeah, not yet, but I'm sure that in future there will be fantastic results on this base. Yeah.
You have to start somewhere, and the best place is where everything is already digital. You don't have to copy and scan handwritten notes from 5 years ago. No, you start everything fresh. Everything is connected. Everything is digital. So it's the best place to start with these AI transformation.
Yeah, I think there are so many factors around the production of a gigacaster, so you need AI to draw the conclusions sometimes.
Yeah. Also, you have people around the machine that have now, during the development phase, also the time to look into what does the system say, what could be interesting, and then learn from these results also to feed back into these, so that you get a constant feedback loop.
Yeah, I think right now there are less than 10% of the machines can really do AI topics or handle the AI topics. No? So we are working on that together with also Bühler or others, no? To get the base for these technologies, and then we can start and improve our processes with AI. No?
I must revert back to Rheocasting. It's my day job. And I must ask you, everybody you talk to at the conference are very interested, and you have a lot of people coming up, and we understand that you're doing a lot of R&D work. Some we know about, some we're not supposed to know about or not know about. Why is it so difficult for the car industry to embrace Rheocasting when telecom and other industries are so much quicker?
Yeah, it's an interesting question, I think. It's a new process. No? You need people who are open for this process. You need a little bit money. And they also use vacuum to get similar results. But at least I think many people don't know this process enough still. No? They have to open themselves to make trials, no? To make, and that's you can do, for example, also at GTK here, many people are joining us. And in most cases, we can really improve the part quality, but you also have to change your die, your mold system, your gating system. You have to open it a little bit, and also the way of gas flow and etc. When you are prepared and ready to test this, then you will be astonished about the results, or can be astonished about the results. But at least somebody in the company has to decide, yes, we will invest or not. And even you have good results, it's not by itself. Somebody has to decide about that. And when you don't have money, it's you cannot invest immediately, maybe later.
No. If you just try it and then do it with the wrong surrounding, wrong gating system, or not done the improvements that you need, you will definitely come to the conclusion that thing doesn't work. And yeah, in that setting, it doesn't work, but it has nothing to do with the technology. It's just it didn't adapt the tool to the technology.
You heard that. I heard Professor Fehlbier starting the description with not many people know about the process. And since I'm the marketing manager, I think I should look for a new job then.
Yes, that's right.
Yeah. Many things we could talk about, but one question that is, I think many people are interested in: when is the next conference?
It will be in 2 years.
Great.
I'm sure we can make a good job again, maybe a better one, because we are now we knew each other. No, we made a lot of contacts and everything, and I think it will improve and get still better than the last time. Even it was very good in my opinion.
It was a success.
Yeah, please don't sell yourself short. I think we haven't talked about the numbers. Can you give us some insights on how many people from how many countries were there?
Yeah, we had about 25 nations and about 419 participants. exactly, in 419, and especially from Asia, from Europe, of course, and North America, about a range of 42% from foreign countries, so not German speaking, no, not from Germany, 42%. I think it's a high value. And about more than 200 companies are joining us. Yeah.
200 companies.
More, a little bit more, yeah. Yeah, and 25 of executions, yeah.
But you were turning registration down. It was more people that wanted to come that you can fit into your lecture room.
I said them, sorry, but the bus is full. We have some seats in some places to stay, maybe the roof or whatever, but it's really full. We cannot get more right now, but maybe next time. Yeah. Yeah, and also the invoice or the payment wasn't perfect right now. You couldn't pay with a card, with credit card, and we will improve that and make it easier for everybody. Yeah.
Yeah, but you're a research institute, not a conference organizer.
That's it. So I said in the beginning, we are we are not perfect, and yeah, we will try and do our best. We promise. Yeah.
Yeah. I think it was running extremely smooth from the registration and students working and to lectures and organization.
Yeah, I was so happy that the technique was running, no interruption and everything, and you never can be sure of that. Yeah.
No, it worked really well, and also from the selected conference topics, from the people that were there. So you had the decision makers, engineers, and then also in the presentation, people were really sharing insights into their processes, and that was quite something unique.
Yeah, we had a lot of talks and telephone calls before, and asking them, can you maybe show a short movie to get an impression of everything, and please show the parts, dual shot, and whatever. No? And we have about 14 OEMs. Yeah. It was very much, and yeah, I think in general, including suppliers, it was a very good conference at least. Yeah, and of course it depends on the participants. No? When they are not there and feel comfortable and everything. I think that the evening location was also very good in the Old Brother Church, and yeah, so all that together was a good cake. Yeah,
we tried to go to our hotel. I tapped Mr. Johnson on the shoulder 10:15, and it was 30 meters to walk, and it took us 2 hours, 15 minutes to walk that because we stopped at every table, discussed alloys, software. So it was a mini conference in walking. Anyway, we know that you have a lot of things to do, Professor Fehlbier. We don't want to uphold you. But again, thank you very much for being with us in the podcast. And again, thank you for a success with the International Gigacasting Conference in Kassel this year. Looking forward to the next one in 2 years. I will set my alarm clock directly of this recording.
Thank you very much, and you're open. Just join us, come us, ask us, and we will improve our collaboration. I'm sure. Now we are very open for you. Thank you. Yeah.
Thank you.
Thank you for that. And then for everybody listening, please don't forget to subscribe. Then you also get the information about the next conference, and then we hear us in the next podcast. See you there. Bye.
Wiedersehen.
Bye. See you.
See you.